Comparing and ordering rational numbers, meeting the requirements for TEKS 62C and 62D. As a reminder, a rational number is any number which can be written as a fraction. That means whole numbers, integers, decimals, percents. Any number that can be written as a fraction is a rational number. I often find that when I'm trying to compare two rational numbers, the first thing I need to do is write them in the same form. Comparing a fraction to a decimal can be particularly tricky. One option could be to change my decimal to a fraction. So to do that, I say my decimal out loud, 35 hundredths, and I write it as a fraction. 35, its digits, over its place value, 100. Now to compare these two fractions, it would help if I made 1/4 share a common denominator with 35 hundredths. So to change my denominator of 4 to 100, I multiplied by 25. I should do the same thing to my numerator, and it would become 25. 25 hundredths is less than 35 hundredths. 25 hundredths has fewer parts than 35 hundredths, so therefore it's less. One other option would have been to change my fraction to a decimal. So I would keep 0.35 or 35 hundredths, and now instead I would change my fraction of 1/4 into a decimal. And when I did that, I would find that I can make no groups of 4 from 1. 4 times 0 is 0. 1 minus 0 is 1. Add a decimal, push it to the top. Add a 0, and bring that 0 down. When I bring that 0 down, I can make two groups of 4 from 10. 4 times 2 is 8. 10 minus 8 is 2. Add another 0, and bring that 0 down. That makes 20. I can make 5 groups of 4 from 20. And 20 minus 20 is 0. My decimal equivalent of 1/4 is 0.25. 0.25 is less than 0.35. In other words, 25 hundredths is less than 35 hundredths. When I compare decimals that share the same place value, the smaller number is the smaller decimal. 25 hundredths is less than 35 hundredths. When I compare rational numbers, it's much easier for me to tell which one is smaller or larger when they're both written as decimals or both written as fractions. Which one you choose is up to you. The best tool to use when ordering rational numbers is a number line. On a number line, we know that as we move to the right, we get greater. The further right we go, the larger the value of that number. We also know that as we move left, we get less. Left is less. On a number line, we can also show fractions. For example, 1/2 would be halfway between 0 and 1. Decimals, 1.5 or 1 5/10 would be the same value as 1 1/2. So therefore, it would fit halfway between 1 and 2. The same thing, of course, would be true going the other way. So negative 1/2 would be halfway between 0 and negative 1, just as negative 1.5 would be halfway between negative 1 and negative 2. the number line can and should be used to order rational numbers. So earlier, I had the fractions 25 over 100 and 35 over 100. And I said 25 over 100 was less than 35 over 100. Now, if I wanted to order them on a number line, the first thing I would want to do is make sure these fractions were simplified. And I can see right away that if I simplified each of them by 5, I would get 5 over 20 is less than 7 over 20. 5/20 is less than 7/20. So if I broke my number line up into 20 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then this would be 1/20, 2/20, and so on, all the way to 20/20, or 1 whole. So I could graph 5/20 right here. This would be the location of 5/20. And 7/20 would be graphed right here, 2 spaces later, 2 spaces further to the right, since it is greater than 5/20. This is what these two fractions would look like graphed on a number line showing that 7/20 is greater than 5/20. Now I could do exactly the same thing with their decimal forms. If you remember, we had 0.25 was less than 0.35. So on a number line, instead of graphing fractions, I'm now graphing decimals. Okay, fine, no problem. So if I said each line, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and so on, where would 0.25 go? It would go halfway between 0.2 and 0.3. This would be 0.25. And where would 0.35 go? Well, halfway between 0.3 and 0.4. Right here. This is where 0.35 or 35/100 would go. Once again, you can clearly see 35/100 is greater than 25/100 since it is further to the right on the number line. Sometimes we can have rational numbers written in the same form. In other words, say 2 fractions. And still, it can be a little bit tricky. Take the case of -3/8 and -3/4. It appears this 3 is almost the size of its denominator of 4, while this 3 isn't even half of its denominator of 8. So I should expect that -3/8 would be less negative than -3/4. And if -3/8 is less negative, then it's greater than -3/4. Now, if that's a little bit confusing, what might help would be to make these common denominators. If I use the least common multiple to find a common denominator, I'm taking multiples of your denominator, 4, 8, 12, 16, 20, or 8, 16, 24, 32, 40. I'm looking for numbers that are on both lists. I see 16, and I also see 8. I want the least common multiple, so I want the lowest number on both lists, which in this case is 8. So -3/8 stays the same since its denominator was already 8, and -3/4 changes its denominator to 8, and to go from 4 to 8, I multiplied by 2. So if I did that to my denominator, I need to do it to my numerator. Negative 3 times 2 is negative 6. So now negative 3/8 compared to negative 6/8. Negative 6/8. That's more negative, which means it's going to be left, right? More negative means less. That means it's further left on the number line. So now that I've compared negative 3/8 and negative 6/8, I want to order them on a number line. So I could break my number line into eighths, since that's a common denominator. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8 would be 1. Or in this case, negative 8/8 would be negative 1. So negative 3/8 would be right here. Negative 3/8. And negative 6/8, which is more negative, would be here, further to the left. Negative 6/8 is left of negative 3/8 since it's less than negative 3/8. Now, what if I were asked to compare and then order a list of rational numbers? What if I had, say, 0.3, 1/2, negative 1/3, and negative 1.4. Now, I could choose to put these all in the same form, or I could look to see if there's some things that I could do logically first. For example, if I drew a number line, right, which of these 4 rational numbers would I expect to see the furthest to the left? Which one of these is the absolute least? Would we agree that the biggest negative would be the lowest number or least value? Negative 1.4 would be the least value of all of these rational numbers. And so if I wanted to plot it on a number line or to graph it, I could put it, if that's negative 1 and that's negative 2, then negative 1.4 is going to be in here somewhere. Negative 1.4. Now, negative 1/3, well, that's a fraction. It's not even all the way to negative 1, so it must be in here somewhere. Negative 1/3. And then on the other side of 0, we know we have 1, 2, 3. 1/2 is going to be halfway between 0 and 1. That's the fraction 1/2. 0.3, or 3/10, all right? 3/10, 0.3 is the same as 3/10. Well, if the fraction 1/2 would be 5/10, 5/10 would be 1/2, then 3/10 must be a little bit less than 1/2. And we could put 3/10 about here. So if I were putting these in order from least to greatest, I would start with negative 1.4 is the least. Then as I go this way, right, I find negative 1/3. Then I find 0.3 or 3/10, and then the fraction 1/2. These 4 rational numbers are now written in order from least to greatest. Now let's wrap up today's lesson. When comparing rational numbers, I suggest writing them in the same form. Whether you choose fractions or decimals is up to you. And then when ordering them, simply remember that as you move to the right, you get greater. And as you move to the left, you get less.